Welcome to Chibuzor Mathphysics. In today's video, we'll continue our series on finding the eigenvalues and eigenvectors. And we are going to be very snappy in this video as we intend to find only the eigenvalues. You can watch the previous video on how to find the corresponding eigenvector. So let's take the question. So we are given a question. Let this matrix A be given by -5. We have -5, we have -7, we have 2, and then we have 4. So these are our matrices. We are required to find the eigenvalues. Okay, so the first thing we are going to do, the solution to this, the very first thing you have to do is we need to locate the eigenvalues of this matrix A by using this equation, the det, that is determinant of A minus lambda, or if I use lambda I, that is identity matrix minus A, and all this must be equal to 0. This implies that we need to multiply this lambda by identity matrix so that we end up with lambda 0 0 lambda. I have multiplied lambda with an identity matrix instead of writing identity matrix, which is 1 0 0 1. So that's exactly what I did. So if you multiply each of these, this is an identity matrix, and when you multiply by lambda, this is what you get. So we simply subtract this with the original matrix, which is -5. We have 2, then -7 and 4, and all these must be equal to 0. This is exactly what we do when we refer to eigenvalues. Computing the determinant of these, this will be, let's bring this together, this becomes lambda. This is going to be lambda minus becomes +5, and this will be -2. We have 0 and 7 here, so it is +7. Then we have lambda -4, and of course all these must be equal to 0. I put this because we are looking for the determinant, so it must be equal to 0. Computing the determinant, you simply take to find the determinant, you simply take this multiply by this, and 7 multiplied by -2. So it will be lambda plus 5 multiplied by lambda -4 minus into 7 multiplied by -2. And if you do that, we are going to end up with lambda squared plus lambda minus 6 is equal to 0, which means that lambda 1 is equals to 2, and lambda 2 is equals to -3 if we solve this equation. So this is exactly what we do in trying to find solution for eigenvalues, and from here now we can use this answer we got for lambda 1 and lambda 2 in order to find the eigenvectors corresponding to these eigenvalues. In case you don't know how we got these, if you expand the bracket, for instance, you simply have lambda into let's just a minute, we'll have lambda plus 5 plus 5, multiply this by lambda minus 4, then minus, we are having negative 2, so we still have negative 2, negative, just a minute, this will be negative 2 multiplied by 7. Okay, so let's expand this. Lambda multiplied by lambda is lambda squared. This gives us lambda squared. Lambda multiplied by negative 4 will give us negative 4 lambda. Positive 5 multiplied by lambda gives us positive 5 lambda. Then we have 5 multiplied by negative 4 will give us negative 20. Okay, negative 20, and here we have negative, so let's have negative 2 multiplied by 7 will give us negative 14, but we have negative outside, so it becomes positive 14. Okay, if we have positive 14, simply bring that together, that will be negative 20 positive 14, that will give us negative 6, that is negative 6. So we have lambda squared. Here we can bring this together, negative 4 lambda plus 5 lambda will give us 1, so it is simply lambda, and it is positive, so it is plus lambda minus negative 20 plus 14 gives us 14, and gives us 6, sorry about that, it gives us 6, and that's how we get this equation, that lambda squared plus lambda minus 6 is equals to 6. So solving this equation, we are able to get the value for lambda 1 to be equals to 2 and lambda 2 to be equals to negative 3. Hope you have enjoyed the video. This is what we do, and this is how you can evaluate and find the values for eigenvalues using lambda. But if we are asked to find the corresponding eigenvectors, then simply substitute this value for lambda where you see lambda, like for instance here we have lambda plus 5, simply put 2 there, and from there we are able to compute and find the eigenvectors. Catch us in the next series as we continue in eigenvalues. My name remains Galagash, and if you are new to this channel, kindly subscribe.